Our new topic is momentum, impulse, and collisions. Today we're going to talk about momentum and impulse. Momentum is a vector quantity. It is the product of mass and velocity. So P is the symbol for momentum, and it has the vector sign above it, which means that it's a vector. In this case, we have an object that is moving to the right. So the direction of the velocity and momentum is the same. So the momentum of this object is going to be to the right. As for finding the magnitude, for example, if we have a 10 kilogram ball moving 1 meter per second to the left, then to find its momentum, we're going to use the formula for momentum, and we're going to take 10 times 1, and we'll get 10 kilograms times meters per second. It's very important to add that it's to the left because, again, momentum is a vector quantity. Another example, let's say we have a 1 kilogram ball and it's moving to the right at 10 meters per second. Momentum, again, is mass times velocity, so we get 1 times 10, which is 10 kilograms times meters per second, but in this case, it's to the right. So are these two momenta the same or are they different? They are both 10 kilograms times meters per second. However, they're not the same because this guy is to the left and this momentum is to the right. So they are equal in magnitude but opposite in direction, so therefore we cannot say that they are the same. Here's a question. If we have two identical vehicles and they are approaching each other at the same speed, are their momenta the same or are they different? They will be different, of course, because they are going to be different in direction. However, they do match each other in magnitude. Let's say we have a 2 kilogram object and a 200 gram object. Will they have the same momenta? They can if, first of all, they move to the same direction, in the same direction, and then the difference in mass, 10 kilogram object is 10 times more massive. So if it's 10 times more massive, then it should move 10 times slower. So let's say if a 2 kilogram object is moving 10 meters per second, then it should be 100 meters per second for the lighter object. And check 2 times 10 is 20 and 0.2 times 100 is 20. So these two momenta are going to be the same if, again, these two objects are moving in the same direction. Here are a few examples. Let's say we have an astronaut. His mass is 45 kilograms. He's wearing a 32 kilogram suit and he's moving, he's running 5.7 meters per second, and he's on the moon. If we were to find the magnitude of both the astronaut and his suit, we would add the masses right here, 45 plus 32, and multiply by the speed. If we were to find the momentum of astronaut by himself, then it would be 45 times 5.7. And let's say if that astronaut was running on the Earth instead of the moon, would his momentum change? Think. If it's mass times velocity, he is jogging at the same speed. His mass is still the same. His weight won't be, but his mass is still the same. So therefore, if force of gravity is different, that doesn't mean that momentum is going to be different. So momentum of the same astronaut running at the same speed is going to be the same wherever he is. Now I would like for you to open your books at page 199 and let's look at some of the problems. Problem 1. We have a deer with a mass of 146 kilograms is running head-on towards you, and you are going north, so therefore the deer is moving south since it's moving towards you. So it's 17 meters per second is the speed. So then we have to find momentum, we take m times v, and therefore momentum is going to be 146 kilograms times 17 meters per second.